All right, welcome to the first video of section 4.6. In this section, we are going to continue solving higher degree polynomials, and you're going to learn some methods that are pretty similar to stuff that you've seen already. So this section is kind of some more practice with one new concept introduced. But in this first video, this is something that we've already been talking about, and most of you guys know already, but it's officially introduced as the fundamental theorem of algebra. And here, this is from your journal, and you can see it's kind of wordy. The theorem says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. The corollary, which is what we focus on, if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2, each repeated 3 times is counted 3, and so on. Basically, what this is saying is that when you have a polynomial, that the degree tells you how many solutions. Now, it says complex solutions, so that means they could be real or imaginary. And basically, we talk about this in class. If there's a third degree polynomial, we know it has 3 solutions. Fourth degree, we know it has 4 solutions. Second degree has 2 solutions, and so on. So this isn't really anything new, but this is just officially kind of declared right here as the fundamental theorem of algebra. This is used a lot more in a lot more detail in higher level math, but it's important to understand. So just as an example, if we look at our first equation, we've got x cubed plus 3x squared plus 16x plus 48 equals 0. How many solutions does that have? Well, you look at the degree, and again, remember the degree, you take the highest exponent in your polynomial, and in this case it's 3. So since it's a third degree polynomial, it has 3 solutions. In this case, it's -3, 4i, and -4i. Now notice, there's 1 real solution and 2 imaginary. So it's still 3 total. Our second one, we see that this is a 4th degree polynomial. So we can tell that that has 4 solutions. And again, here we see that the zeros are -2, -2, -2. So we've got one that's repeated 3 times. So we still count that as 3 solutions. And then 0 is the 4th. So we talked in a previous lesson about repeated zeros. I think it was last lesson. So when we're talking about the number of solutions, just remember that the degree is equal to the number of solutions. So what I want you guys to do is go ahead and answer the questions that pop up now about these 2 equations.